Alrighty, so we're jumping into our Vegie room file here so that we can start to import some carrots. Okay, so the first thing we need to do right up here at the top is we're going to say from objects import carrot. Okay, put a little bit of space at the top there. And then once we've got our carrot, this is where we're going to start to put it in. So we can say carrot underscore object equals carrot. Let's make sure we get all of our spelling right. Self 400 300. Okay, so what we're saying here is we are just going to set its position to the 400th pixel on the x-axis and 300th pixel on the y-axis. And then self dot add underscore room object carrot object. Okay, so again, we set up that variable so that we don't have to type this in each time. It's just going to make things much faster. Now, we have our carrot now on screen. We also have our carrot ready so that if it's clicked, it will delete itself. Okay, so if we now run our game, so I can now just come up and sort of quickly press this play button, move our thing, you can see that our carrot's sitting here on screen, and when we click on the carrot, it deletes itself. Okay, so that's going to make our game actually work, but now we obviously need to make it a little bit more interesting because our carrot, if it's just sitting in the same spot, it's going to be a very boring game. So we need to add some more code for our carrot in our Vegie room file. The first thing we're going to do is import the random library so that we can get our carrot to start moving in a random direction. And then from there, we're going to have carrot underscore object dot set direction. Okay, and from there we want random.randint. Okay, and we're going to say 0 to 359. And then, whoops, I have missed a bracket here. Okay, and then we want to have a 8 there, so that's going to be its speed. Okay, so this one should actually look like that. So it's random.randint bracket 0, 359, close those parentheses for our angle with a comma and then the speed of 8. Okay, so that's what we're setting there. So this is going to get our carrot to now start moving. So again, if we quickly test the game, press the play button, move it on screen, you can see that our carrot moves, but eventually it just jumps off the screen. So we need to check to see if our carrot is going to stay on the screen or not, and make sure that we can keep it there ready to go. So we're going to add some more code to our carrot.py file, and this is going to make sure that we keep our our carrot on the screen at all times. So this code here actually goes so this code here that we're going to add actually goes into a new function. So we're going to call this define step. Okay. And from there, we're just going to have self, which I didn't need to type in. And then we're going to add some stuff that tests for our X and Y position. So tests X position. Okay, so that's what we're going to do first up, is just test our X position, and then we're going to reverse our direction if we need to. So from there, we will have if self.rect.left is less than or equal to 0, or self.rect.right. Okay, so we're grabbing a couple of different things here, is greater than or equal to globals.screen, and then for our X-axis, we want width. Okay, we're going to then say self.x underscore speed is now equal, or sorry, is going to be multiply equals -1, and self.x equals self.previous underscore x. So we're going to grab a previous position and just quickly move back one spot, and then whatever the speed is, okay, we're going to multiply it by -1. And the reason why we're multiplying it by -1 is so that it always reverses, because if we're moving in a negative direction, negative times a negative equals a positive, and if we multiply our positive by a negative because we were moving in a positive direction, a positive multiplied by a negative equals a negative. So we're going to always flip our direction. Okay, but what we're actually searching for here is if the position of our carrot in terms of its left edge is less than or equal to 0. Okay, 0 being the left edge of the screen. Or our right edge of our carrot is greater than or equal to our global screen width. So that's sort of over here on the right edge. It will run this code here and then flip it. So we also need to then go and do the same thing for our y-axis. Now what I'm going to do here is I'm going to cheat a little bit, and I'm just going to copy and paste that code and then make the changes as I need to. Now it's important to make sure you get your alignment correct, so make sure that if you do paste it in like I did and it moved over one indent, that we move it back. But this one is going to test our Y position, and what we want to do instead is say if our rectangular side of our top is now greater than or equal to 0, or our right, instead of right, we're going to have bottom. We are also changing here from width to height, okay? Now the rest of it, it's just a matter of changing x's to y's. Okay, so you can see here that the code is largely the same, because now instead of testing the left side of the box, we are testing the top of the box is less than or equal to 0. And then instead of setting the right hand side, we are checking the bottom of the box instead. And this one we're comparing against the screen height rather than the width. Again, we just multiply this time our y speed by -1, and then we are setting our y position by previous y. So what you'll notice now is that if we press play and have a look at our game, it tells us that we do not have globals, which is because I forgot to import them at the top. Okay, so now that I've imported globals from GameFrame, it actually knows what these two values are. So we can press play there, and that'll move on screen and then bounce around so that our carrots stay on the screen. So that's really good. So obviously our carrot is now good to go. All right. And then the only other thing we're going to need to do, which is not a huge problem at the moment, but when we have more carrots and our bombs on screen, we're going to have to set up a function here for our carrot so that it bounces off each other, because we don't want them to just go through, because that'll make it a little bit too easy. Okay, so we might do that right now, even though we don't have 2 carrots on there. So the first thing we want to do is have something that listens for, or like handles the collisions. Okay, and to do that, all we're going to say is self.register_collision_object, and we want to check the carrot. Okay, and I'm going to cheat again here. Actually, we can't, because we won't be able to test it. So I'm just going to have that one there. And then we need a new function that actually runs some code for us. So we're going to say define handle_collision. Okay. And then we want self and other, which is great. And then we want self.bounce other. Okay, so we're just going to basically sort of reverse our direction there when we collide with something. So this means now that we can start adding some extra carrots to our level file, and then we can basically go about setting up some bombs and stuff like that as well. Okay, so I'm going to stop this video here. We're going to add some code to our veggie room for some more carrots, and then I'll show you how to very quickly set up a bomb. Okay, and then that'll be it for the entire game.